A variable star is a star whose brightness as seen from Earth fluctuates. This variation may be caused by a change in emitted light or by something partly blocking the light, so variable stars are classified as either intrinsic variables, whose luminosity actually changes, for example, because the star periodically swells and shrinks; extrinsic variables, whose apparent changes in brightness are due to changes in the amount of the light that can reach Earth, for example, because the star has an orbiting companion that sometimes eclipses it. Many, possibly most, stars have at least some variation in luminosity. The energy output of our Sun, for example, varies by about 0.1% over an 11-year solar cycle. Discovery. An ancient Egyptian calendar of lucky and unlucky days composed some 3,200 years ago may be the oldest preserved historical document of the discovery of a variable star, the eclipsing binary algol, of the modern astronomers. The first variable star was identified in 1638 when Johannes Holweder noticed that Omicron Ceti pulsated in a cycle taking 11 months. The star had previously been described as a nova by David Fabricius in 1596. This discovery, combined with supernovae observed in 1572 and 1604, proved that the starry sky was not eternally invariable as Aristotle and other ancient philosophers had taught. In this way, the discovery of variable stars contributed to the astronomical revolution of the 16th and early 17th centuries. The second variable star to be described was the eclipsing variable algol, by Geminiano Montanari in 1669. John Goodricke gave the correct explanation of its variability in 1784. Chi Cygni was identified in 1686 by G. Kirch, then A Hydra in 1704 by G. D. Maraldi. By 1786 10 variable stars were known. John Goodricke himself discovered Delta Cephei and Beta Lyrae. Since 1850 the number of known variable stars has increased rapidly, especially after 1890 when it became possible to identify variable stars by means of photography. The latest edition of the General Catalogue of Variable Stars lists more than 46,000 variable stars in the Milky Way, as well as 10,000 in other galaxies, and over 10,000 suspected variables. Detecting variability. The most common kinds of variability involve changes in brightness, but other types of variability also occur, in particular changes in the spectrum. By combining light curve data with observed spectral changes, astronomers are often able to explain why a particular star is variable. Variable star observations. Variable stars are generally analyzed using photometry, spectrophotometry, and spectroscopy. Measurements of their changes in brightness can be plotted to produce light curves. For regular variables, the period of variation and its amplitude can be very well established. For many variable stars, though, these quantities may vary slowly over time, or even from one period to the next. Peak brightnesses in the light curve are known as maxima, while troughs are known as minima. Amateur astronomers can do useful scientific study of variable stars by visually comparing the star with other stars within the same telescopic field of view of which the magnitudes are known and constant. By estimating the variable's magnitude and noting the time of observation, a visual light curve can be constructed. The American Association of Variable Star Observers collects such observations from participants around the world and shares the data with the scientific community. For the light curve, the following data are derived. Are the brightness variations periodical, semi-periodical, irregular, or unique? What is the period of the brightness fluctuations? What is the shape of the light curve? For the spectrum, the following data are derived. What kind of star is it? What is its temperature, its luminosity class? Is it a single star, or a binary? Does the spectrum change with time? Changes in brightness may depend strongly on the part of the spectrum that is observed. If the wavelengths of spectral lines are shifted, this points to movements. Strong magnetic fields on the star betray themselves in the spectrum. Abnormal emission or absorption lines may be indication of a hot stellar atmosphere or gas clouds surrounding the star. In very few cases it is possible to make pictures of a stellar disk. These may show darker spots on its surface. Interpretation of observations. Combining light curves with spectral data often gives a clue as to the changes that occur in a variable star. For example, evidence for a pulsating star is found in its shifting spectrum because its surface periodically moves toward and away from us, with the same frequency as its changing brightness. About two-thirds of all variable stars appear to be pulsating. In the 1930s, astronomer Arthur Stanley Eddington showed that the mathematical equations that describe the interior of a star may lead to instabilities that cause a star to pulsate. The most common type of instability is related to oscillations in the degree of ionization in outer convective layers of the star. Suppose the star is in the swelling phase. Its outer layers expand, causing them to cool. Because of the decreasing temperature, the degree of ionization also decreases. This makes the gas more transparent, and thus makes it easier for the star to radiate its energy. This in turn will make the star start to contract. As the gas is thereby compressed, it is heated and the degree of ionization again increases. This makes the gas more opaque, and radiation temporarily becomes captured in the gas. This heats the gas further, leading it to expand once again. Thus a cycle of expansion and compression is maintained. The pulsation of Cepheids is known to be driven by oscillations in the ionization of helium. Variable star nomenclature. In a given constellation, the first variable stars discovered were designated with letters R through Z, e.g., our Andromedae. This system of nomenclature was developed by Friedrich W. Argelander, who gave the first previously unnamed variable in a constellation the letter R, the first letter not used by Bayer. Letters R through RZ, SS through SZ, up to ZZ are used for the next discoveries, e.g., R Lyrae. Later discoveries used letters AA through AZ, BB through BZ, and up to QQ through QZ. Once those 334 combinations are exhausted, variables are numbered in order of discovery, starting with the prefixed V335 onwards. Classification. Variable stars may be either intrinsic or extrinsic. Intrinsic variable stars. Stars where the variability is being caused by changes in the physical properties of the stars themselves. This category can be divided into three subgroups. Pulsating variables. Stars whose radius alternately expands and contracts as part of the natural evolutionary aging processes. Eruptive variables. Stars who experience eruptions on the surfaces like flares or mass ejections. Cataclysmic or explosive variables. Stars that undergo a cataclysmic change in the properties like novae and supernovae. Extrinsic variable stars. Stars where the variability is caused by external properties like rotation or eclipses. There are two main subgroups: eclipsing binaries, double stars where, as seen from Earth's vantage point, the stars occasionally eclipse one another as they orbit. Rotating variables. Stars whose variability is caused by phenomena related to the rotation. Examples are stars with extreme sunspots, which affect the apparent brightness, of stars that have fast rotation speeds causing them to become ellipsoidal in shape. These subgroups themselves are further divided into specific types of variable stars that are usually named after the prototype. For example, dwarf novae are designated U Geminorum stars after the first recognized star in the class, U Geminorum.